All right, in this review problem, we're going to take a look at 430, and we're going to prove by induction that the sum of j equals r to n, j choose r, is equal to n plus 1 choose r plus 1, as long as n is greater than or equal to r. And the proof of this will be by induction. So proof by induction on n. Now this is supposed to be true for n greater than or equal to r. So the smallest possible value of n that I need to worry about is equal to r, where r is some fixed number. So n equals r is my base case. On the left-hand side, I have summation j equals r to r of r choose r, of j choose r, j choose r. On the right-hand side, I would have r plus 1 choose r plus 1. Now, on the left-hand side, if this is a sum with only one term in it, j equals r, so if I plug in j equals r, then that's my first and my last term. On the right-hand side is r plus 1 choose r plus 1, which is true, because both of those are equal to 1. If the top number is equal to the bottom number, then the binomial coefficient is equal to 1. So that's true. Now, n equals k. Assume that. Summation j equals r to k of j choose r is equal to k plus 1 choose r plus 1. We now move on to the case of n equals k plus 1. N equals k plus 1, the left-hand side becomes summation j equals r to k plus 1 j choose r. And let's just write this out. R choose r plus 1 choose r plus k choose r plus k plus 1 choose r. That's what this summation means. Now, the first few terms of this, from here to here, that's the induction hypothesis. That if I add these together, that's equal to the right-hand side. That's a summation of j equals r to k, j choose r. If I were to write it out, it would be these terms here. So by induction hypothesis, the first few of these would be k plus 1 choose r plus 1. Then I would add on this extra term, k plus 1 choose r, by induction hypothesis. Okay, now here I have two binomial coefficients that are being added together, same row and adjacent columns. And so by one of our theorems about binomial coefficients, I know that I can add these together to get k plus 2 choose r plus 1. If I take this entry in Pascal's triangle plus this entry plus Pascal's triangle, I get an entry in the next row of Pascal's triangle. That's a theorem about binomial coefficients, which can be verified by examining, writing these all out in factorials. Now that matches the form. If j is equal to k plus 1, I have k plus 1 makes k plus 2 choose r plus 1. And so that's my target, and so that is the end of the proof. So this was a fairly straightforward problem by mathematical induction.